Okay, take a look at this example here about how we might answer these questions about this function. First question is the point 2 comma negative 7 on this graph? Well, all we have to do is look at what f of 2 is. In other words, we put 2 in for the x's, so that would be 2 plus 7 divided by 2 minus 9. So here we have 9, and on the bottom we would have 2 minus 9, which is negative 7. And let's see, we're supposed to have a minus 7 there. Well, 2 plus 7 is 9. 2 minus 9 is negative 7. This number is not negative 7, so I'm going to say nope, it is not. Alright, next the question is asking us if x equals 4, what is f of x? Well, when x equals to 4, then all we want to do is take a look at f of 4. So we're going to look at the value of f when x is equal to 4. So that means 4 plus 7 divided by 4 minus 9. 4 plus 7, well, that's 11. And then 4 minus 9 is negative 5. So we can write that as negative 11 over 5, which is fine. And also, what would the point be on the graph? Well, it would be 4 comma negative 11 divided by 5. That would be your point right there. Okay. Let's see, if f equals to 2, what is x? Well, that's, f of x equals 2. That means we're going to put in 2 for basically y, so we'll have the equation, which is going to be 2 is equal to x plus 7 divided by x minus 9. And what I can do here is multiply both sides by x minus 9. On both sides here, x minus 9. Okay, and then that's going to give us, on this side, 2x minus 18 is equal to, well, these cancel out here, so x plus 7. Subtracting x, we get x, and adding 18, we get equals to 25. Okay, so when x equals to 25, we should get 4 out of this, 2 out of this equation. And we do, and the point on the graph would be 25, comma 2. Okay. Alright, the next question is about the domain. The only thing we have here is that we don't ever want to divide by 0, so we need to look at the equation when x minus 9 is equal to 0. I think you can see that's when x equals to 9. So we want to say x cannot equal to 9. That's one way to say it. If you want to do it in interval notation, though, you can do it like this. You can say from minus infinity all the way to 9, and then you put a union, and then you go from 9 all the way to infinity. That's how you do an interval notation. Or you can do it with an inequality like that. Depends on what they ask for. Alright, so let's look at the intercepts. For the x-intercept, we want to put in 0 for y, so we'd have the equation which would be 0 equals to x plus 7 over x minus 9. Approaching it the same way, multiplying both sides by x minus 9, you get 0 equals to x plus 7, because x minus 9 would cancel here, and it would hit 0 over there, and then that means that x is equal to negative 7. So then we would have the point minus 7 comma 0 on the graph. And that's going to be the x-intercept, x int period. Okay, and the last question says list the y-intercept. The y-intercept is when x equals 0, so it'll be 0 plus 7 divided by 0 minus 9, which is equal to 7 over negative 9, otherwise known as minus 7 ninths. And you would have minus 7 ninths with a 0 in for the x, and there would be your point on the graph. Okay. Alright, let's take a look at how we might do this using a graphing calculator. First thing you want to do in the graphing calculator is, well, let's hit this y equals to here. Make sure you have none of these plots up here highlighted. When it be highlighted, it would look like that. And you see, you just have to go up on top of it with the arrows and turn it off with the enter sign. Then you want to enter in the function into y1 like so. Make sure you use parentheses if you have to. Some of the better calculators, you can have an actual fraction there. but on this one you have to do it this way. And then we can go ahead and look at the table here, but before we do that, a preliminary step would be to go to the table set, go second and then window, make sure that the independent variable is on ask right there. That's the case, so then what I can do here is come over here to actually the table. And you can see I've put the number 2 in for x, and y has come out to be negative 1.286, which I think we saw was a fraction before, but it is clearly not negative 7, so we can automatically get the answer to that question right away by saying here, just by looking at the calculator, we can call this one no. Okay, let me get that calculator back up and running. Okay, and then if x is 4, well, we can put 4 right here, and we can see that y is going to be negative 2.2. And if we go back to the main screen, one of the cool things we can do is take that negative 2.2, hit math, and we can turn it back into a fraction, and I think we saw that was the answer from before. Okay, and then we can also do something with the table here where we can say, take a look at the y-intercepts. You put in 0 for x, and you get this y-intercept here. Notice it's negative 0.77. I want to put the screen, or the cursor right on there. See, it's actually negative 0.77777777. And if we do that on the main screen, we can get negative point, a bunch of 77777. It rounds to 8 eventually, but we'll just do that. Have it change math back to a fraction. You can see that it's the negative 7/9 that we got before. Now, doing the other few things here is still a little bit more advanced, so we'll stick to this part for right now on the calculator. Okay, for this question here, it's asking where some of the intervals for where it's increasing or decreasing. So we can take a look at this. As you can see here, the interval from minus 10 to minus 8, so the interval, you do that with a parenthesis on it, make sure you make a parenthesis here, minus 10 to minus 8, the function is going down, or it's decreasing. Decreasing. Sorry for the bad handwriting, it's the pen. I can blame it on something. Now from minus 8 all the way into minus 2, it's increasing. Notice I'm using x values here. Okay? That's an 8, by the way. That's a funny looking 8. Okay, so but from minus 8 to negative 2, so we can say from minus 8, I did it again. Let me do that better here. Okay, from minus 8, we'll do it this way. From minus 8, oh my goodness, it's not even as good. Having a difficult time with this pen. Minus 8, there we go, close enough. All the way to negative 2. Notice these are x values. From minus 8 all the way to negative 2, it is increasing. Okay, so looking at that, we can go all the way and follow this along here. So from negative 2 to 0, it's decreasing. And from 0 all the way to this value, which is at the positive 2 for x, so 0 to 2 is increasing. Remember, these are x values. Okay, and we can also have a constant one. When it goes straight across, it could be constant. Okay, this is a piecewise defined function, and notice that they want to know what f of minus 3 is. So what you want to do is look at f of minus 3, and that's going to be, let's see, f of minus 3 is what they ask. So that means x is equal to minus 3. Okay, so which category is that? Is that less than 0, equal to 0, or greater than 0? Well, I think it's this one right here, right? It is, because minus 3 is less than 0. So we put minus 3 in for x, and we square it. And the reason we're using this one is because it's in that category, and that equals to positive 9. So you can say f of minus 3 equals to 9. Okay, so if we want to look at f of 0, then what we have to do here is we have to put in x equals 0. So for f of 0, we can see x equals to 0, and that's this category. And we already know the answer is minus 1, so f of 0 equals to minus 1. And then f of negative, or f of positive 4 would fit this category. So f of positive 4 would be 2 times 4, that's 2 times 4, plus 1, or 9. So f of 4 equals to 9. F of 4 here is equal to 9. Okay, and that's all you have to do. Alright, we'll just take a look at one more for this homework here. They're asking for the domain. Well, you can see that x can be as low as it wants to under 1 and as high as it wants to above 1. In other words, from 1 here and going down this way is everything, and from 1 to greater. So actually the domain here, the domain, is going to be all real numbers. So you can actually say that the domain is domain is all real. Now in interval notation, that's minus infinity all the way to infinity. Those are funny infinity signs, I know, but that's how you do that. It's a comma right there, comma. Okay, that's how you find the domain. To locate any intercepts, we probably should go ahead and graph the function first. That'll be easier. So let's go ahead and graph the function. For all x is less than 1, it's the line y, or f of x. We'll do y is equal to minus 3x plus 5. So we're going to have a line that starts at 5. So I'll put a point here at 5. All right, and then we're going to go down 3 and over 1, down 3 and over 1. But it's only going to be good for values that are bigger than 1. Less than 1, excuse me, less than 1. So we're going to have to do something a little weird here with this graph, since we don't have a good, here's 1, it's going to go down 3 and over 1 would be here. So yeah, that was where we would have it right there. Let's put a line through that. We'll make this one blue, I think. So we'll put a line here. We'll go, I'm sorry, here, we'll get this one started. And it'll go up this way. There you go. Let me see if I can get it through there. Okay. And then for values greater than or equal to 1, we have the equation right here that y is equal to 3x minus 1. That means we're going to start at minus 1, but it's going to be weird because we're not going to use any x's until we get to 1. So this one goes up 3 and over 1, up 3 and over 1. So it's actually going to start right there and then go through this point up here. And let me go ahead and make a line through that. Okay, there you go, and that's going to be our graph. And you can see from here that the only intercepts are going to be at 5. So the only intercepts we have are a y-intercept here of y int, and it's at the point 0, 5. Notice this graph never does hit the x-axis. Now, as far as the range is concerned, it gets down to what looks like to be 2 right there when x is 1. So we're going to say that the range, we'll call this the range, is going to go from 2, notice I'm using a bracket because we can get to 2, all the way to infinity, and use a parenthesis on infinity. That's called interval notation. Okay, so there's some fun things in here. We'll do more with the calculator in the next video.